Good evening. Today we are going to learn about special sequences. Your I can statements for this evening are: I can determine if a sequence is a special sequence, and I can understand and recognize the Fibonacci sequence. Some new vocabulary for tonight. A special sequence is any sequence that is not arithmetic or geometric. Now what that means is, to get to the next term in this pattern of numbers, we're not going to add to get to the next term, and we're not going to multiply to get to the next term. Or at least we're not going to add by the same number each time or multiply by the same number each time. So let's look at a few examples. Here's your first example. We got 1, 3, 6, 10, 15, 21, 28, 36, 45. Now if you'll notice, between 1 and 3, we're adding 2. Between 3 and 6, we're adding 3. So right there should tell you it's not arithmetic. Now 1 times 3 gives us 3, but 3 times 2 is what gives us 6. So that tells you it's not geometric. So this is in fact a special sequence. It is a triangular set of numbers. These numbers are triangular numbers because they are generated from a pattern of dots which form a triangle. By adding another row of dots and counting all the dots, we can find the next number in the sequence. As you notice here, this is the first term of the sequence. There is 1 dot. The next term or number in the sequence is 3. Notice here we added a second row. We had 1, 2, and then we had the first row of 1, so there's 3 total. Over here we have 6. If we add a third row with 1 more dot added onto it and count all the dots, we get 6. That's our third term. Same thing here. When we add a fourth row, add an additional dot, add them all up, we get 10. And then if we add a row of 5, we're going to get 15. Now, if we add a 6th row, we're going to add 6 to 15, and that's where we're going to get the 21, and so on. Some more examples of some special sequences. Here we have 1, 4, 9, 16, 25, 36, 49, and 64, and 81. Now notice here we're adding 3, we're adding 5. Okay, so it's not arithmetic. We multiply by 4. If we multiply by 4 here, we should get 16, so it's not geometric. The numbers or terms in this sequence are found by squaring a number, so we call them squared numbers. To get 1, we have to square 1. 1 times 1 is 1. To get 4, we have to square 2. 2 times 2 is 4. To get 9, we have to square 3. To get 16, we square 4, and so on. Okay. Now, for the next example, we're going to look at this set of numbers. This sequence is going from 1 to 8 to 27 to 64, 125, all the way up until we get to 729. Now obviously we're not adding a number to get to the next number each time. Here we would add 7, and then to get here we would have to add 19. That's not what's going on. This is not arithmetic. It cannot be geometric either. 1 times 8 gives you 8. But 8 times 8 would give you 64. You're skipping the 27. So this is also a type of special sequence. These numbers are cubed numbers because the next number in the sequence is found by cubing a number. 1 cubed is 1. 1 times 1 times 1. 2 cubed is 8 because 2 times 2 times 2 is 8. 3 cubed is 27. 4 cubed is 64, 5 cubed is 125, and so on. And now for the most famous special sequence of all is, drumroll please, the Fibonacci sequence. We have 1, 1, 2, 3, 5, 8, 13, and 21. Now you may be asking yourself, what kind of pattern is shown there? Take a moment to pause the video and just See if you can determine what the pattern is. Now, hopefully you figured it out, but if you haven't, let's look. The Fibonacci sequence is where the first two terms are ones. Here's 1 and 1. And any term thereafter is the sum of the preceding two terms. For instance, we started with 1 and 1. So to get the next number here, we must add the two numbers in front of it. So 1 plus 1 is 2. To find the next term in the sequence, we got to add the two numbers in front of it. 1 plus 2 is 3. To find the next term, we got to take the two numbers before it and add it. So 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. 8 plus 13 is 21, and so on. This is a very, very special sequence. And to be honest with you, it's as famous as a sequence can get and is pretty much worth the knowing. Now, let's go back and review our I can statements. I can statement number 1. I can determine if a sequence is a special sequence. Hopefully you're able to do that now. Knowing that a special sequence is one in which it is not arithmetic nor geometric, then you should know how to find out if it's a special sequence. I can understand and recognize the Fibonacci sequence. To remember, it's the most famous sequence of all. Thank you guys so much for paying attention, and I look forward to seeing you in class tomorrow.